Welcome to Mad Dentists. Case control study. Often called retrospective study, this study has three distinct features. 1. Both exposure and disease occurred before the start of the study. 2. The study proceeds from effect to cause. 3. It uses a control group to support or refute an inference. Basic steps in case control study. First step is selection of cases and controls, second is matching, third is measurement of exposure, and the final one is analysis and interpretation. In selection of cases and controls, we require cases and controls. So, what are they? Case. Control. Definition of a case requires two criteria. Diagnostic criteria of the disease. Eligibility criteria. Diagnostic criteria of the disease, if any, to be included in the study must be specified before the study is undertaken and should not be altered or changed until the study is over. Eligibility criteria. Only newly diagnosed cases within a specified period of time are eligible than old cases or cases in advanced stages of disease. Source of cases. Hospitals. General population. Hospitals, often it is convenient to select from hospital admitted during a specified period of time. General population, all cases of the study disease, occurring within a defined geographic area during a specified period of time are ascertained, often through a survey, a disease registry or hospital network. The entire case series or a random sample of it is selected for the study. Selection of controls. Controls must be free from the disease under study. Similar to the cases, except for the absence of disease. Sources of controls. Hospital controls. Relatives. Neighborhood controls. General population. Hospital controls may be selected from the same hospital as the cases, but with different illnesses other than the study disease. Sibling controls are unsuitable where genetic conditions are under study. Neighborhood controls may be people living in same locality as cases, persons working in the same factory, children attending same school. General population controls can be obtained from defined geographic areas, by taking a random sample of individuals free of the study disease. Failure to select comparable controls can introduce bias into results of case control studies and decrease the confidence one can place in the findings. Matching. Matching is defined as the process by which we select controls in such a way that they are similar to cases with regards to certain pertinent selection variables, for example sex, age, which is known to influence the outcome of disease and which, if not adequately matched for comparability, could distort or confound the results. So, what is confounding factor? A confounding factors is defined as one, which is associated both with exposure and disease, and is distributed unequally in study and control groups. For example, role of alcohol in the etiology of esophageal cancer. Smoking is a confounding factor because, it is associated with the consumption of alcohol and it is an independent risk factor for esophageal cancer. The effects of alcohol consumption can be determined only if the influence of smoking is neutralized by matching. While matching, it should be borne in mind that the suspected etiological factor or variable we wish to measure should not be matched, because by matching, its etiological role is eliminated in that study. There are several kinds of matching procedures. Group matching. This may be done by assigning cases to subcategories based on their characteristics, for example age, occupation, social class, and then establishing appropriate controls. The frequency distribution of the matched variable must be similar in study and comparison groups. By pairs, for each case, a control is chosen which can be matched quite closely. Thus, if we have a 50-year-old Mason with a particular disease, we will search for 50-year-old Mason without disease as a control. Thus one can obtain pairs of patients and controls of the same sex, age, duration and severity of illness, etc. Measurement of exposure. Information about exposure should be obtained in precisely the same manner for both cases and controls. This may be obtained by interviews, questionnaires, past records, cases and controls. Analysis and interpretation. Exposure rates. In cases equals A divided by A plus C, 2, controls equals B divided B plus D. The estimation of disease risk relative risk is equal to incidence among exposed divided by incidence among non-exposed. Odds ratio is a measure of the strength of the association between risk factor and outcome is equal to AD/BC, bias in case control study. Bias is any systematic error in the determination of the association between the exposure and the disease. Memory or recall bias, selection bias, interviewer's bias, bias due to confounding, Bergsonian bias, memory or recall bias. When cases and controls are asked questions about their past history, it may be more likely for the cases to recall the existence of certain events or factors than the controls who are healthy persons. So the same habit or any complaint may trigger you to think in such a way you come into wrong conclusion. Selection bias. The cases and controls may not be representative of cases and controls in the general population. There may be systematic differences in characteristics between cases and controls. The selection bias can be best controlled by prevention. Interviewer's bias. Bias may also occur when the interviewer knows the hypothesis and also knows who the cases are. This prior information may lead him to question the cases more thoroughly than controls regarding a positive history of the suspected causal factor. This type of bias can be eliminated by double-blinding. Bias due to confounding. Confounding is an important source of bias. This bias can be removed by matching in case-control studies. Bergsonian bias. This bias arises because of the different rates of admission to hospitals for people with different diseases. It is termed after Dr. Joseph Bergsonian, who recognized this problem. Case control study advantages. Easy to carry out. Rapid and inexpensive. Few subjects are required. Rare disease can be studied. No risk to subjects. Allows study of several etiological factor. Risk factors can be identified. No attrition problems. Ethical problems are minimal. Disadvantages. Problems of bias. Selection of appropriate control group. Incidence cannot be measured. Not distinguished between causes and associated factors. Not suited to the evaluation of therapy. Concern is representativeness of cases and controls, for example, 1. Thalidomide tragedy, 2. Maternal smoking and congenital malformations. Thank you.